Hello, my scholars. I decided to make a quick video to show you how to solve for these electromagnetic radiation math problems. So let's look at this one. We have photon energy. It says a photon has a energy of 3.97 times 10 to the negative 25th joules, and we want to find out the frequency. So we know that photon energy equation is E equals Planck's constant times frequency. And we're solving for frequency. So that means frequency is going to be E divided by Planck's constant H. So let's start giving. We have 3.97 times 10 to the negative 25th joules. And we know Planck's constant because that number never ever changes, to the negative 34 joules second. All right. So with this, it's pretty simple. To solve for frequency, all we have to do is plug and chug the numbers we've been given. 3.97 times 10 to the 25th joules divided by 6.626 times 10 to the negative 34 joules second. Now, because there's joules in the top and there's joules in the bottom, those joules are going to cancel out. And we're just going to be left with whatever the number is when we divide these two per second. But before I get into that with you, I need to show you how you use your calculator to type this scientific notation number. So you would say 3.97. This feature is our scientific notation. It means times 10. So you don't have to hit times 10. You just hit EE and you type in the exponent negative 25. So you say negative 25. Then you're going to hit divide by 6.626. Then you hit the EE key again and you hit negative 34. And voila, there's your answer. Oh, wow, that did not come out in scientific notation. However, we could count over. We want the decimal point to go in between the 5 and the 9. So we go 1, 2, 3, 4, 5, 6, 7, 8. So the answer, the frequency would be 5.99 times 10 to the 8th. We're going to call it hertz, which is number of waves per second. So that's how you solve for problem 18. Okay. You must show all your work just like this when you do your problems for your tests. All right, let's go to the next problem. Here we have on the next screen, problem 19. What is the frequency of electromagnetic radiation that has the wavelength of 2 times 10 to the negative 12 meters? Okay. So we write our our list, what we've been given. We have been given wavelength, which is 2 times 10 to the negative 12 meters. The question is asking for frequency. Oh, I didn't mean to write the F. I meant to write the little Greek letter, frequency. And when you have frequency and wavelength, we know to use the speed of light equation. Speed of light is C equals wavelength times frequency. So we're trying to solve for a frequency. Therefore, frequency is going to be speed of light divided by wavelength. So now we must take speed of light, which is a constant, 3 times 10 to the 8th meters per second, and we're going to divide it. So what is this? So we're going to take, what is this? We're going to take 0 times 10 to the 8th meters per second divided by our wavelength number, which is 2 times 10 to the negative 12 meters. Meters are going to cancel out, and we're going to be left with some number of waves per second. So let's pull up our handy dandy calculator. We type 3 EE, and since the 8 is positive, we don't need to hit the negative sign. Then we divide it by 2 EE negative 12. And we get 1.5 times 10 to the 20th. And our answer is going to be hertz. And that's how we solve that problem. Remember to show our work when you do these math problems in science. So let's go to our last problem, problem number 20 from the study guide. What is the photon energy of wavelength 3.46 times 10 to the negative 9? Oh, this is a little different. Only thing we've been given in this problem is wavelength times 10 to the negative 9 meters. But since we're solving for photon energy, we know that equation is E times Planck's constant times wavelength. So another thing we do, we do know Planck's constant, so we could write that down as one of our known variables. But we do not have frequency. How can we solve for this? We also know something called the speed of light. So we could use the speed of light equation, which to solve for frequency. So frequency using speed of light is speed of light divided by wavelength, because we know speed of light. So we're going to do like a little substitution. We're going to take this equation that's used to solve for frequency with the speed of light and plug it into there. So let's do just that. Let's take our speed of light and divide it by our wavelength. Okay, meters to cancel out. We pull up our handy dandy calculator. We say, oh, clear the screen, 3EE8, positive 8 that is, divided by 3.46 EE negative 9 gives us that number, 8.67 times 10 to the 16th hertz. Now that we have our frequency number, we could plug it into the energy equation. So Planck's constant times our hertz, which is 867 times 10 to the 16th. I'm going to just put per seconds so we can see the units cancel out. This seconds here on the bottom is going to cancel out with that seconds from the Planck's number. And we're going to multiply these two numbers. So I already had the 8.67 in the calculator, so all I have to do is hit times 6.626 EE negative 34. And it gives us this. So photon energy for this problem is 5.74 times 10 to the negative 17 joules. Okay, so that's how you solve for electromagnetic radiation using these two equations. And that's how you use scientific notation with your calculator. I hope this video helps.